Good day, everyone. So I'm here to continue the chapters electric field in physics. So in my previous video or class, I have done the introduction to electric field, field line, Coulomb's law of electrostatics, both in magnitude form and in vector form. And we solve numerous questions on it. And I also explain how we can use Coulomb's law in vacuum or in free space, and how we can use Coulomb's law when the medium is not in free space, not in vacuum. So that's where we stopped in the last class. So in today's class, our major interest is to deal with systems of charge. System of of charge, either in the straight line, in triangular form, or in rectangular form. So after that, we will move to the electric field intensity, electric potential, work done, equal potential, surface, and then we end up to the Gauss law of electrostatics. So let us start from systems of of many charge. So this system of many charge is a branch of of electrostatics. We deal with the various way of using Coulomb's law to determine the Coulomb's law, and using Coulomb's law by it to determine the magnitude of force that acted on a particular charge. But in this case, if you look at the Coulomb's law, it deals with two charges. But in this system of many charges, you have two or more charges that is present in the system. If you have a system that is comprised of two or more charges, like 3, 4, 5, 6 charges, how are you going to know the net force or the magnitude of of the force, the net force, which is the resultant force of of the many charges? Before we can know that, we apply what we call superposition theory. Let's go. System of many charges. So if if the n charge in a system, in a system, each charge we experience force from other charge. If there is n charge in a system, each charge will experience force from other charge. Yes, and the resultant force on the charge can be obtained by using the principle of superposition. Yes, I said if there is a what? N charge in a system, this N charges means what? The charge we have in the system is more than 2. The N stands for the number of what? Of charges in a what? A system. And each charge will experience force from each other. And the resultant force on this charge can be determined by what? Superposition what? Theory. Take for instance here, assume we have a straight line in this form, and this straight line here, we have a charge here, we have another charge here in the middle, and we have what? Another charge here. See, the charge we have here, assume is positive, and the charge we have here, assume is what? Negative. The charge we have here is what? Is positive. So that is, let's call the first charge here Q what? Let's call it Q1, this one Q2, this one Q3. Forget that the distance between the two charges here, know that the distance here is what? R1. The distance here is R what? R2. And the total discharge between here and this side, let me say, the total distance, call it what? R what? R3. Good. This is a good example of what? N, a system of what? Of N charges. This is a system. This N means what? Number of charge we have on it. How many charge do we have in this system? We have 3. Q1, Q2, and Q3. Distance between the what? If this Q1 is the origin, so the distance between Q1 and Q2 is R1. Between Q2 and Q3 is R2. But between what? The origin, yeah, and what? And Q3 is what? Is R3. If you are now asked that what is the effective charge, or what is the what? Or find the net force on Q1. We have to find the what? The net force on what? On Q1. You will know that what? There is a force that is called between Q1 and Q2. And there is also a what? An electric force which occur between Q2 and what? And Q3. Q1 and what? And Q3. So we can now see that what? In this diagram alone, we have like 3 what? Force. But one force experienced here, another force is experienced here, another force is also what? Experienced here. The force may be repulsion or may be attraction. It depends on the kind of charge we have. Between Q1 and Q2, what kind of repulsion force? What kind of force we have here? This is negative, positive. We have force of attraction. Between Q2 and Q3, what kind of what force do we have there? Attraction. Between Q3 and a Q1, what out of the force do we have there is what force of repulsion. So if you are now asked, what is the what? The net force. Net what? Net force on Q1. The net force on a Q1 means what? This Q1 is stationary. We will now try to what? The Q2 will insert force on what? On Q1. Q3 will also insert force on what? On Q1. So like this now, look at what? This Q1 is stationary, right? We are taking our net force on Q1, Abi. We now keep Q1 aside, like this. So between Q1 and Q2, between what? Q1 and Q2, what kind of force exists between them? The force exists between Q1 and the Q2 is force of what? Attraction. At what? Attraction. It tells us that what? This positive charge will move toward what? Toward the Q2. Abi, if that be the case, the vector diagram for this Q1 and Q2, it will be in this form, and this will be the what? Direction of the force. This force is now be what? Force of charge 1, where what? Q2 is inserted force on. We call it what? This is the Q2 that what? Is exact insert is what? It's force on what? On Q1. Call it what? Force F12. The force is coming from what? From this, and this F2 Q1 will move toward the what? The negative. Why? It will attract. This is a vector diagram for what? For Q what? Between Q1 and Q2. So the second thing is what? Let's consider the Q3. Q3 is positive. Q1 is what? Is positive. So is it Q1 going to what? To attract, to move toward the Q2, 3? Never. Because both of them are what? Are of the same charge. Here, the Q2, Q1 move toward the what? The Q2. Why? They are what? They are opposite charge. But here, this Q1 have positive charge. Q3 also have positive charge. So this Q1 can never move. This what? Q1 can never what? Move toward what? The Q3. Why? Because they are of the same kind. It's what? It will repel. When it's repel, it will move along the side. So along this side, you will be the what? The force of what? Of F1 to what? To Q3. So to now know the what? The net force on what? On this Q1, let's say what? You need to use what? This principle of superposition. But assume we have what? 4 system of charge, which is Q4. We need to consider what? Q what? Q1 and what? And Q4 too. So this is how the what? We deal with what? System of what? Of charge. So before we can know the what? The net force, let me explain the principle of what? Of superposition. Principle of superposition. Superposition. So this principle of superposition, it states that the net force acting on a charge is the vector sum. Let me put it on board. It what? States that net force acting on charge is the vector sum of all individual of all individual force acting on this charge from other charges. This principle said that what? The net force on this Q1 acting on a charge is what? Is the vector sum of all individual force acting on this what? Charge from other what? Charge. That is, it says that what? The net force will be, look at the net force. Net force should be equal to the what? The force F1 plus force what? F2 plus F what? 3 plus up to the what? Fn infinity. So that is what? The super what? Position. He said the net force on this Q1 is the sum of what? Of individual force that is active on what? On this Q1. From this analysis now, we have how many forces on this Q1? We have force of what? 2, 1, 2, and force of what? 1, 3. Force of 1, 2, and force of what? Of 1, what? 1, 3. So, what is the net force from this diagram now? To know the net force of this diagram, you can now say what? Net force will be equal, if you could still remember, let me say the net force will be equal to the what? To the vector sum. Vector what? Sum. Supposed to be what? F1 plus F2 plus F3. But look at this F13 and F12. They face what? Different direction. In a vector analysis, if two parallel forces are what? Are face different direction, we will subtract. If they face the same direction, we what? We will add. So in this case now, we will subtract the less force from what? From bigger what? Force. So we don't know the one that is what? That is heavy. Here, we can now have what? Here we have force. The one that the heavy say F what? F12 minus force 1, 3. It depends which of the two is what? Is bigger force. So if this one is what? Is more than this, you subtract this from what? From this. This is what we call super what? Superposition. Yes. And this system of many charge in Coulomb's law can be grouped into what? Into 3 parts. So the system of many charge can occur. One, we have on a what? System of charge on a straight line. On a what? On a straight what? Straight line. We can also have a system of charge on a triangle. On a what? Triangle. This on a straight line can exist in both vertical form and on a what? Horizontal form. So on triangle, this triangle we can have it in what? In isosceles triangle. What? Triangle. We can have it in what? In equilateral what? Lateral triangle. We can have it in what? In a scaling triangle. And the third one is what? The system of charge can also occur in what? On a square. Or we can also have it on what? On a rectangle. On what? On rectangle. Good.